Germany?
Yes, I'm in Germany on holiday right now. So I totally understand what you guys are talking about in the Northern Hemisphere about it getting cold. Dear Lord.
Yeah. It's like summer is so easy, have all the windows open and just like easy. But then when it gets cold, then it's like everything gets complicated. So it's good though.
Yeah.
All right, you're looking sharp, man. I like your hairstyle. You're like exploded.
Thank you. Thank you.
Okay. All right. So what I think, Kevin. So I'm before you jump in, I want to. Oh, we have a lot of new people coming, so that's good.
We need to have, once it gets bigger, we need to have like a more formal process for who speaks and when. And also if the internet is not good, like if there's a delay, then it's extremely difficult to talk because we talk over each other.
Yeah, the latency creates like, it's difficult to like, know when somebody is actually going to speak at the same time.
Exactly.
Because there's this like 150 millisecond window sometimes. I don't know how bad latency actually is, but where people can actually start talking, he's talking yet.
Yeah, so I tried to get my internet upgraded to fiber, and I had this guy come on Wednesday, and then they never showed up. And then I called him, and there's all this, and I guess I can't get it at my place yet. So, but I was able to sign up for it, but then I couldn't get it. So, but whatever.
All right, cool. So let's do this way. So basically, today's topic is about the Sighash Flags. So I have a very short presentation, probably less than 5 minutes. So once I finish, I think Kevin, you can talk about your stuff, your understanding, and then we can go from there. How about that?
All right, great. That's perfect.
All right, let me start it actually. By the way, hello guys, you guys. It's a Bao, right? I think it's, welcome here. Samir, welcome here again. You can speak. Feel free to speak anytime if you guys have any questions. Okay. So let me guess. Hey. Okay. So Sighash flags. So prerequisite, basically Bitcoin signatures. So before I talk about Sighash flags, we need to understand how signatures in Bitcoin work. I think you guys probably heard about this called the ECDSA. So basically is you have a message, right? And you have a signature algorithm. I think we just in Bitcoin using this called ECDSA, digital signature algorithm. So basically you have the message, you have the private key, and then with these two, you go through this algorithm, you can generate digital signature. It's almost like a handwritten signature, such that nobody can, for example, after you sign a signature, sign a transaction, nobody else can just change it because otherwise it's not good, right? For example, instead of sending to Alice, sending to Bob, then somebody can intercept it and change it to, let's say, Mallory or Charlie, right? And also you don't want people to change the amount also. Instead of sending, let's say Alice only want to send 1 Bitcoin to Bob, and then it turns out Bob can intercept it and change it to 10. That's not good neither, right? So the digital signature most need to first authenticate and also to protect the integrity of the transaction. So once the receiver have the signature, what else does he need? He also needs a original message, and also he needs a public key. So with these 3, he can check whether signature is valid or not. So this is how usually a digital signature works in at least the ECDSA. So here's a question here, right? So what is the message we are signing? This is the concept called Sighash preimage. Basically, the reason it's called preimage, hash preimage, is because instead of signing messages, which can be arbitrarily long, right? You can imagine like you can even have megabytes or even gigabytes message later on. So you don't want to sign, usually it's very computationally expensive. So you don't want to sign the whole thing. Instead, you always hash it first, and then you sign it. So that's why you call it a signature hash pre-image, right? So before you sign it, you want to hash the original message, and then only sign the pre-image of it. So I just draw a very simple diagram here. So basically, imagine you have two transactions, right? You have transaction 0 and you have transaction 1. And we know the UTXO model, right? So let's say this has 3 outputs, and the transaction 1's first input is spending the second output for transaction 0. So if you're spending this way, this is the locking script is here. So when you have check sig here, check sig is basically the opcode to check the signature, validate the signature. So if you have a check sig here, what is the pre-image you are assigning? So actually is this part. Roughly, I think I'm not going to go into all the details. You can have all the field. Basically, if you really want to do it, this is the specific field you're assigning. But just keep it high level. You're assigning the UTXO itself and also the spending transaction. That's about it. So that's a default case, right? Sighash pre-image, and that's where the Sighash flags come into play. So Sighash flags, what does that mean? So by default, right, you're assigning, when you sign the UTXO, it's always covered, right? And also you sign the spending transaction. But actually, you can modify which part of the transaction you are assigning depends on your use cases. So for example, here, you can see you have transaction, you have inputs, you have outputs, right? And this highlighted is signed, otherwise it's blank, it's unsigned. So by default, the flag is called all. So basically you sign all the inputs and all the outputs. But you also have other 3 flags called none, single, and anyone can pay. What does none mean? Of course, just literal meaning for all these 3, it only says what outputs I'm putting into the pre-image I'm signing. So all means all outputs. None means none of the outputs. Single means if I'm so come back here again. So this is the input I'm locking, right? So single means just at the same index, the output. I'm also signing, for example, here I'm unlocking some UTXO, right? I can see a single. So that means only the first output is included in pre-image. So what does this mean? If it's none, right? You can actually, whoever has this signed transaction, he can mutate, he can manage the outputs to whatever he wants. So for example, it's almost like a blank check, right? You just give somebody the money and the check, and then you ask him to fill in an amount and who's going to the amount he wants to take is like a blank check. So single means, for example, let's say I want to have for example, I want to send some money. I only control the full amount. Let's say together I have 10 Bitcoins, and when I sign the transaction, I say, oh, 1 has to go to Alice. I don't care about the rest. You can do whatever you want. So that's single. So out of all these 3 control the outputs, right? There's another, like anyone can pay. So literally means you can, if you combine with its combination with all the previous 3, basically means I only put my inputs. You can add whatever inputs you want, right? So the inputs is like you are contributing the funds, right? Think about it. You have a crowdsource, right? Let's say, oh, I want to, crowdsource to the, let's say sCrypt project. I'm donating 1 Bitcoin, and I sign this, and whoever wants to contribute can add that input here. I don't care. For me, I'm only adding 1 output, 1 input containing 1 Bitcoin. You guys can add anything else you want. So basically with all these 4 flags, you can have 6 combinations covering different parts of the spending transaction that's going to the Sighash pre-image. So you can have you can basically customize which part you go into. So anything that's not signed, so that can be changed, right? So I just talk about a few cases. You can have arbitrary cases you can think of, right? That can leverage this Sighash types. So I'm going to stop here. So hopefully it's short. And any questions so far? Or Kevin, you want to have a quick comments?
Sure. So yeah, the original reason I actually had a bunch of realizations. I understand it quite a bit better. But the original time I saw all this, I had no idea what it was for. I didn't see any significance in doing this, or why is it here, or any of that kind of stuff. But what I realized is that I had an oversimplified model of how the UTXO model worked in my mind. And I thought that you would just put in a key. You just like put in your private key into the stack in order to unlock the UTXO, you see, but then in that case, you'd be revealing your private key.
You don't want to do that. Okay. You can do that, but
and then and you don't want to do that, right? Well, yeah. Okay, so yeah, but you can, but then you would lose your private key because it'd be on the record of there it is in the stack. And so what I realized is that the reason we're doing a signature is in order to allow us to inject the private key into the stack in a private way.
Yes.
So I hope that makes sense. And so so then once I understood that, then I understood, oh, okay, I see it. But so, and then all of it clicked for me of what's the pre-image and what is the yeah, just what the pre-image and why it's called Sighash flag. Anyways, it's so complicated, and I wish I could draw this out with diagrams and stuff. But the website that really helped me was Learn Me a Bitcoin.
Learn Me a Bitcoin.
And yeah, because I'm a very visual person. But yeah, it was that YouTube video where I realized that, oh, we can't just put the private key in the unlocking script. I mean, you could, but then you would reveal a private key. And so we have to have another way of showing that you have the private key without revealing the private key. And so that's why we sign the transaction. So anyways, I hope that makes sense. I had a realization. Okay, good. And so yeah, so now I'm just trying to understand. So when you do the anyone can pay, you're signing. So multiple people can basically. So, but multiple people can sign the same transaction, perhaps.
Yeah, usually multiple
it's called
people.
anyone
Otherwise,
can pay.
Yeah, anyone you can pay, right? Basically, add inputs. That's like your contribution. So I think there's one very famous usage in Bitcoin history. That's actually called the Lighthouse, started by Mike Hearn. So basically, you have some public goods, right? It's like a lighthouse, in near the cliff of the ocean. Everybody can benefit it if you are like a ship coming into the harbor, but a lot of time, you don't want to just yourself want to find it. So it's a community project. So what anyone can pay in that case is, let's say I'm sending this, I'm only signing the output, saying, okay, I have at least 10 Bitcoins go to, for example, the organization that's trying to build the lighthouse, right? And then I'm adding my 1 Bitcoin. So if I give this transaction to anybody, because the input is only 1 Bitcoin and output is 10, right? You cannot spend it because the input amount is less than output. It's not a valid Bitcoin transaction. So the only way to make it valid is other people contribute 9 or more in total. Then that's how it becomes valid, right? So that's why you're like crowdfunding, but also in a trusting way, saying I'm donating 1 out of 10 Bitcoins. So only when it reaches the minimum, the money goes in, and nobody can take the money, right? That's one of the first usage I heard.
Essentially, what it does is it enables other people to add additional inputs to your transaction.
Yes.
Because if you don't
Right.
use the anyone can pay flag, you essentially lock the input part of the whole transaction. So no more inputs can be added, only outputs depending on the flag use. But if you use anyone can pay, anyone can add an additional input to the. Right.
But I'm wondering how to do that. Like, I'm just trying to wrap my head around how that would look, because my oversimplified model was just to look at the little, what we call contract, but I like to think of it more as a locking script. That the thing that we're writing in sCrypt is like a locking script for a contract. And then it's difficult for me to visualize in that oversimplified model that this is actually a representation of multiple people that are going to be creating multiple inputs. So I'm just curious. I guess I just need to see more code examples of how the sig hashes work, and like, why would you use this one and not this one? See what I mean? I understand the crowd raising example, because you only want it to unlock if it reaches a certain amount, right? It's like if you're having a party, like my older brother always would say, you know, like, make sure you can get the 3 best friends, you get them first before you announce the party, or something like that. And it's kind of the same thing with this. It's like, if you're gonna raise a bunch of money, you want to see that there actually is a certain level of interest before you're actually going to do it. And so yeah, I get it. I get the significance of the anyone can pay, but I don't understand the significance of all these other ones. So like with none, you're only signing the inputs, but you're not signing any of the outputs.
Yeah, pretty much. It's like
So
you're
is that like
donating
an
money.
Return, or?
You're like giving out
Blank
money.
check of sorts.
Yeah. Anybody
So
can
anybody can
take
just
money.
unlock it?
Not unlock. It's already unlocked. Right?
Oh,
anybody can fill in the outputs. I can say, oh, this has 10 Bitcoins in total in the inputs, right? I can take the transaction. I'm saying, oh, I'm giving 9 to Kevin, 1 to Ted, right? I can do that. I can decide where the money goes. There's no constraint. It's a blank check. With the upper limit.
But it's a blank. But is there still a locking? You still have to create a new locking script, right? For an output.
Somebody does, but you don't.
Yeah, you can. Basically, it's already signed. So here, right? So this is the locking script here. This is the previous transaction, right? This is the spending one. So if it's a none, basically the guy already put the signature in the inputs here in the unlocking script. That's already set. But the only part is you can change the outputs here. So you can dictate where the money goes. Because usually you cannot change the output, right? Because otherwise it's not good, right? If I'm sending you like 10 Bitcoins, you can change if somebody intercept it, let's say Charlie, right? He can then steal your money, right? Usually you don't want that to happen, but in some cases, for whatever reason, right?
You gotta be careful with the none.
Yeah, this one you have to be careful.
I can't see all the faces.
Charlie,
I heard somebody laughing. I can't see
Charlie
face.
definitely wants to steal your money, and so Wallet will definitely attempt to intercept your coins. But I think that one thing which, as I'm listening, right, which might not be obvious, is that when we're talking about the spending transaction, I think it is probably important to just remind everybody that we're talking about multiple people modifying the spending transaction off chain. So If you're basically creating a spending transaction with SIG none, you probably don't broadcast that, and then you pass that on to somebody else who will broadcast it and then fill in complete the outputs. And the same for when you, for example, have the lighthouse example, where you have multiple people modifying the transaction, one transaction to add additional outputs. That transaction is modified offline. So you essentially have to have offline infrastructure that allows for this transaction to be passed back and forth offline between multiple people before it becomes spendable. So that is the aspect that I think is important to remember, that we're talking about modifying the transaction offline and potentially passing it between multiple parties for offline modification before broadcast.
Okay, that makes a lot more sense. Thank you. Because I was always looking at these as this is how it is on chain somehow, and then somebody's going to modify that and it's going to be recorded on chain. But what's happening instead is you have to inject your private key into the thing without revealing what it is. And so you need a method of, if you're going to have multiple people participate in a transaction, you have to way of passing this thing around without revealing your private key. And so you do these Sighash things.
Well, your private key would be more like a pen, and not like the signature that is being created by the pen. And so picture each of us has our own pens, and finding it, but each of us keeps our pens, and at the end all of our signatures are on the paper. In the case of Sighash none, you would have generally a lot of the parties would be trusted, and you would have them sign with Sighash none, or usually, I don't know what, well maybe, well I think Sighash none is interesting for a number of reasons, but at the end I would think normally you'd have somebody like finalize and sign with Sighash all before you broadcast, and that way someone can't take that take that last finalized thing and then just take it apart after it's been broadcast and take the money out of it. So normally it would be combined with another input that later adds a Sighash all or something to it, so that it's kind of more locked in place in that. But in terms of private keys, yeah, I mean, I think of them as the keys would be more like a pen, and they write this signature. They're the only one that can write that signature, or the person's hand holding the pen or something. And when we're doing these transactions offline before broadcast, it's like we have this piece of paper and we're all passing it around and signing it and putting the things together and negotiating our contract, or not contract, but arrangement for building this lighthouse or whatever the case may be. And then at the end, we broadcast it out, and then it gets registered on the network after things have been locked in place. Now, in terms of Kevin, what you mentioned with these sCrypt locking scripts that we have, right? And how does that kind of, what you can do is you can write sCrypt code that compiles into a locking script, right?
Right.
That locking script, you can have a certain amount on it. And then now you know what that script is, and you know what the amount is. So that's suddenly an output, right? And then once you have that step completed, instead of just funding that with normal inputs, you could, pardon me, you could fund that with, you could fund that with inputs that were funded through, suppose I have an sCrypt contract for something, and then I compile the code, and then I associate, the amount of, 100 BSV to it. Now that is a fixed output that I've defined with a locking script and an amount. Then I can take that and I can have people sign it with, Sighash, anyone can pay, Sighash single, or whatever the case may be. And maybe they only each add 10 BSV, and then 10 of them add 10 BSV or something like that, and it just gets passed around until the transaction becomes valid. And now you have this live UTXO, which is associated with an sCrypt contract that has been funded by a transaction created using various types of funding methodologies through Sighash or something like that. So maybe that makes it a little bit more clear about why, or how you can get them it's kind of a way to fund things, right? A way to get money into the transaction, and then a way to sign off on certain parts of it. So maybe that makes a little more sense.
Yeah, it's all helping. I'll watch it back and just try and understand it better. But I think yeah, it's a way. I guess there's a more fundamental question that wasn't addressed before we started talking about Sighash in the tutorial series, which is fine. It's just I'm not criticizing, but I'm just saying how I got confused is we needed to have a more fundamental question, which is why are we signing this message? Because I just had this super simple representation in my mind, a low resolution representation that when I'm writing a sCrypt contract, I'm just creating this single locking script. But I didn't understand all the intricacies of this is going to be signed.
The context around it.
Yeah, the context around it. But I've understood it a lot better this week. But that was a big block for me because I just had a low resolution understanding of what was happening.
Yeah, another key, I think maybe that's the part, if I have to guess, that's what's a little bit making it more confusing for you is the private key never shows up anywhere on the blockchain or in a script.
Yeah, exactly. Exactly. And it obviously it can't.
Yeah.
Because
you cannot. Yeah. That's why usually that's called a zero knowledge proof, right? So when somebody sends you some Bitcoin like regularly, they send it to your address, right? Which is pretty much you can think about it's your public key, right? So you want only the person who knows the corresponding private key can move the coins, right? Because otherwise anybody can move the coins. The Bitcoin is almost, the system breaks down, right? So you need to have some kind of like almost like access control or authorization.
Knowledge barrier.
That's the script. Yes.
Sorts.
So you think about it, it's like a zero knowledge thing. I want to prove I have this private key corresponding to the public key, but I cannot show you the private key directly because otherwise, right, you can steal my money. So the way to do it is the digital signature. The signature can show you I possess the private key without exposing the private key itself. So in a blockchain and also when the script is running on the stack, the private key never shows up. It cannot show up, right? Otherwise it can be stolen. Yeah.
Right. And so I guess one of the first things I said, so let me just let you know what goes through my head when I see these slides. This is what a totally naive person looking at these slides. So go back to the last one.
Yes.
So when I first saw this, my question is, what the hell is the message? And I'm like, did he mean transaction?
This is the message. Yeah, this is the message. Yeah, being signed, right?
But the message was the first time. Okay, go ahead.
You want to sign the message, right? Basically, in cryptography, right? You have message, you have encryption or
I know that.
So the message, what are you signing, right? You have to sign something. What is the data you are signing? The data you are signing in Bitcoin context is called the signature hashing per image, because you first hash it and then you sign it, right? So that's why the name. So this part was circled. This is the message you are signing, the data.
Right. I think generally the context was just laying the groundwork for generally how digital signatures would work, and then later on we got into the Bitcoin specific context.
Yes, exactly. But for me, the term message confused me because I didn't know. And then when I got to here, I got confused that this arrow is pointing from right to left instead of from left to right, because I would assume it just made more logical sense to me that it'd be transaction 0 goes to transaction 1.
Well,
but you're saying
spending
this input on the right is referencing the one on the left, and I understand that. But then it's like, well, why doesn't this one below it have an arrow? Because that's referencing one of them, but it doesn't have an arrow either. But I guess this must have this.
Yeah, here's the part,
coming
right?
from an outside another transaction, maybe, right, in the graph.
It can be from you can spend from here. It doesn't matter. Basically, when you look at one check sig, basically, right? Check sig is here, right? You know that this is locking script. So the signature checking happens here, right? So in this case, whoever is unlocking, the signature part actually goes in here, right? So this is check sig opcode here, signature come here, right? So this signature has a signature, the sig hash type. All right.
Okay.
But
I
in
see.
here,
Oh, I
this is
see.
totally
I see.
different.
And so then,
You can have another signature spending from somewhere else. You can have a different signature types. So each input, the signature types can be is independent from other inputs, even if they're in the same transaction. You choose it, right? So if you go,
so maybe, okay.
if you really want to go technical,
If you
this,
go,
yeah, this Sighash preimage, right? The last for at the end, this is Sighash types. So if you actually, you can go to a, you know, let's do this actually. So it's all clear. So you want to get visual, right? You cannot be even visual than the mainnet, right? Let's go to what's on chain, right? I hope this is visual enough. So good thing is most of them have check sig, so if not all. So let's go to the latest block and find one transaction, right? By the way, this is not scripted, neither this is improvised. Okay, let's see. So here you have script, right? Let's say this, you have one input, one output, right? So one input is spending from here. Let's go to the script part.
okay. Before you continue, I can't see the whole screen. Is that
You
true for
cannot
other
see that?
people, or is that?
Can
you guys see the whole screen or just a part of it?
I can see Chrome.
Okay, yeah, now I can see.
Let me see, how do I?
Okay, there, now I can see. Now I can see all of Chrome. That's helpful, yeah.
Is this good
You
enough?
have to move a little bit to the right.
To the right, right? Oh, okay.
Just so I can see all of Chrome. So
Can
if
you
you
see?
just move like, yeah, but now a little bit to the left. And then,
It's good enough?
yeah,
Oh,
that's fine, yeah. Perfect, just stop it
Somehow
there.
it's not. Okay, okay. So here, right?
Yeah.
This is a Sighash flag. Did you see here? So
okay, so hold on. Let me
Yeah.
first understand where we are, because I don't even understand all of this stuff.
Okay.
So if you scroll up a little bit, so first we're on the scripts part. So
Yeah, this
are
is
we
the
on the
input,
transaction? Right? So you clicked on the transaction. Okay.
Yeah, this is a transaction. You have one input.
Okay, so this
output.
so we're in block. We're in a block.
The latest block, yeah.
So
it's a.
And then this is a transaction in that block at this time. I'm just reading through all this stuff. Okay, and then this transaction has one input and one output. I understand that. And then you clicked on scripts.
Yes.
Which I have no idea what this is.
Just the scripts corresponding to each of the inputs and outputs.
Yeah, basically this.
The locking and unlocking scripts.
Yeah, this locking script here, unlocking script here, right? So that's what it's showing.
Okay, yeah, and this is for each of those transactions.
Yeah, this is for the inputs.
Sorry, I was trying to click through it myself, but I can't.
Yeah, let me actually send in the group actually. I'm sending in a Slack.
Well, no, I was trying to point at it so you could see what I was pointing at, but I couldn't. It's just, I don't know, it's just hard with the overtake. I'm trying to get the right routine here so I could explain what I'm talking about. Okay, so then you have the input and outputs. So this is just a new way of looking at that original tab.
Yeah, this is like
scroll up
zoom in
and then click on that tab.
Yeah, this is like zooming.
Yeah, it's like zooming in. Okay.
Yes.
So we looked at details, and that was the overview. And then you pressed on script, and it gives you more details for each of those. So this is the same input that if we go to the details page would be there.
It's the same.
And then that's the same output. Okay, I see. Okay, so now I understand that context. Okay, so now we have that. So now you can explain what you're going to talk about. So you highlighted all in ForkID. Yeah,
this is Sighash types, right? This is all. Basically, it's signing all the outputs for this transaction. So if actually let me go this JSON. This may be clear. So if I go to this is again, this is called script 6.
Okay, well, hold
Basically,
on. Now I don't even understand. I don't
this
even
is a
understand what this is.
this is a
So
JSON
then-
version of the transaction, right? You have inputs,
Oh, I see,
outputs.
okay.
This you have log
Okay,
time,
so-
you have version, right? It's a JSON
Oh, I see.
form. It's the same thing, but in JSON format. So it's easier to see.
Got it. So what they should do is have it be like the JSON is first, because this is the, well, I'm not saying they should, but just for my thing, like this is the rawest form, but you could actually probably get even more
It was
raw.
raw, or believe me.
Yeah, it's
It's raw.
that thing on Learn Me a Bitcoin where it's all put together, and then somebody has to keep track of how many characters, and then you split it how many characters.
Yeah.
Okay, so JSON is like, let's
It gets
not
a
say the
silver
rawest,
medal
but
for
pretty darn raw.
rawest.
Mhm.
Yeah, and
kinda
then
raw.
the detail tab is a way of, can you click on it just so I can look at it?
Mhm.
The detail tab. I'm just trying to get my okay, so then this is just a more polished way of seeing what's in the JSON. And then the scripts is a way of
Only showing
looking
the
at
script.
these, just the inputs and
Mhm.
outputs.
Just
But
the
it's just
script
showing
part.
but it's the same inputs. Yeah, okay.
Mm.
And then okay, that kind of makes sense.
I want to maybe just add one more thing, right? For the sake of clarity, to try and tie it back to the original diagram with the two transactions, TX0 and TX1. Just to maybe clarify that we're looking at one transaction here on what's on chain. So this would be TX1 that we're looking at with the
Yes.
inputs green
Right.
and the
Mhm.
outputs in orange for TX1. That we're
Right.
not actually looking at TX0 inputs and outputs. Is that correct,
Mhm.
Xiaowei?
Yes,
Not correct.
Exactly.
Correct, right?
Yes.
So what we're looking at on what's on chain right now only relates to TX1. And
TX1.
there's nothing to it. Yeah, only TX1 inputs and outputs on TX1.
Yeah.
Yes.
Yes. Okay. Yes. I get that. And so yeah. So but then why is this thing in red? So we're signing the input. Is that so? Hold on. Go back to the thing before you just flipped away from it. This thing. So what is this red? And I'm not trying to criticize this at all. I just am trying to understand. That's it. You know what I mean? It's just because so that you know what I know, because you're asking how do you know if people understand or not? So now I'm being like the dumbest person in the room, which is hopefully helpful to other people that have no understanding too. So this is a benefit. But I look at this and I had, like no idea why this thing is circled in red and why the arrow is from the but now I get it. So when we were looking at that page, we were just looking at transaction 1. But then this thing that's circled in red is the Sighash pre-image.
Yes.
What you're essentially looking at is not only like in transaction 1, you're specifically looking at the context of execution of the first input.
Yeah.
Because you have, if you have many inputs in a transaction, each one of them gets executed with another like locking script, like for example here the second one in TX0, right?
Yes.
And you do that for every single input, and each of the time the actual pre-image can change. It depends on the inputs, on the flag in the input, right? And if single one of them is wrong, then the whole transaction cannot be spent, broadcast, right? Because miners won't accept it because it will be false.
Yeah, and that's really helpful to make the distinction that we're doing all of these off-chain. So and this is where the term message must come in, because when you said we're signing the message, it's like, well, what do you mean the message? Are we signing the transaction? But no, we're creating some sort of message that we're going to broadcast to the network, and that's going to become a transaction. I think that makes sense.
Yeah, this is a message being sent. Basically, it's called just different name. Right?
Okay.
Message is a generic. Just in Bitcoin transaction signature, this is what the message is about. So if you're ready, let's go to the block Explorer again. I think this will get you crystal clear.
For this.
Okay, no problem. So I think this is
sorry to interrupt you, Xiaowei. I really sorry to interrupt, but I maybe also want to add that what is being signed, I think that for me, what confused me about the Sighash pre-image was that we're not signing the pre-image, but a hash of the pre-image.
Yeah.
So yes, we're indirectly
Okay,
signing
yeah.
the pre-image, but we're hashing the pre-image and then signing that hash.
Yeah, that's why I call it
which is a shorter.
yes. Yeah. That.
Okay,
that,
so let me say that in my words, and you can correct it. Or go ahead, Chow, and then I'll say it.
Okay, that's why it's got a. It's not signature pre-image, right? It's got signature hash pre-image because you hash the pre-image first. The reason is in cryptography,
Yes, okay.
there's a signing.
Okay.
It's
So then,
computationally expensive. You don't want to sign like a 1 GB raw data because that takes a lot of computation. Instead, you hash it. Let's say 256, and then you sign. Then it's much faster. Go ahead.
okay, so then the pre-image. So the pre-image is essentially all those things that you see on Learn Me a Bitcoin. And I'm going to pull it up. It's all of these things.
It's all that has been circled in
Remember
this
this?
slide.
Yeah, it's what's in this circle.
Okay,
basically.
so so it's all that's circled in that slide. Thank you. Okay, so that's what
That's what the
that's what
pre-image
red line
The
is.
pre-image.
Okay,
yes.
so the red line is the pre-image.
Right.
Yes.
Then we're gonna hold on. Let me finish. So and then we're gonna hash that pre-image, and then we're gonna sign
Yes.
it.
Yes.
And so that's where the whole
Exactly.
term Sighash pre-image comes in. Okay.
Yes.
Okay.
Mhm.
So the red line, just for clarity, the red line is the pre-image. Then we're gonna hash that because we don't want to have to. And you know that's what this thing is. That is in the slides. And we're gonna hash that to make it smaller, and then we're gonna sign it. Okay, that all makes sense. And then okay. All right. So I'm up to speed, so you can continue if you wanted to change the website.
Yeah.
Because Stefan started the interruption. You're gonna say something before that.
Mhm.
We're gonna go to the block explorer, I think, and look at the
Now
input.
we're back.
Yep.
Yeah. So I think
Yep.
this is so-called this is a specific type of contract, which is usually called a pay to public key hash, right? Because this is the hash of the public key. So this is address. Basically, you can think of this as address. So this is a specific contract, right? So in this contract, so here, okay, before I go, let me actually do this. So
I would look at the input first.
yes, let's look at the inputs. Actually, I think it's spending this UTXO. Let's click there, go there.
Now we're looking at TX0.
TX0. Actually,
But when we go to UTXO,
let's not. Somehow it doesn't take me there. Should I click this one?
should say via and then a TX ID on the.
Yeah, that's what I
name.
clicked. Somehow it's not what I expected.
Huh.
You see this? Let me
Strange.
actually. But anyway, don't worry about this.
It's
So
just
let's
a
come back.
lot of things in that one transaction.
Yeah.
It has like
So
10
basically-
outputs.
We'll see. Look,
Yeah. I'm
Well,
sure if you
okay.
go there, you can still
So
see
basically-
it's almost the same locking script, right? Just this one's different, right?
Yeah.
So you can see the same thing. It does, this is the signature checking opcode. Basically, it checks whether you have the, the private key corresponding to this public key, the hash of the public key, okay? So this
right.
checks it.
Okay.
So you need
Yes.
to push in the locking script, you must have the signature, which is this part, right? And let's go. The signature, I think you can, this is the signature. Does it make sense? This is the whole thing. This is the signature. And the end of the signature,
Okay. So hold on.
you have the signature hash type, sig hash types.
Yeah, the Sighash type. Okay. Okay. So when you said this is the signature, so this is the input, and so
This is actually the public key, by the way, and this is the signature.
that. Okay. So that's the signature of the public key. What does the ASM stand for?
Oh, assembly.
Script sig.
So script,
ASM,
you can
assembly.
have
Okay, so
yeah. So come here. That's where we easier. So the script, you can have two forms to show it, right? Either hex, which is very hard to understand, right? So if it's hex, nobody knows what's this, right? Usually when it's more human readable, it's an assembly mode. So you can see the opcode, right? It's basically like a deassembler. go from hex to assembly code.
Okay, so hold on. So that's the script pub key, and you can view that in ASM form. You could view it in hex form,
Yes.
and then these are just some details about it. So it's the
Yeah.
pub key hash type, request sigs. What's that?
What is the
That's,
request? Oh, don't worry about
Right.
this. Don't worry about that. I
That's-
don't
Okay,
that's
know.
not
all right.
relevant.
I won't worry about it. But I'm just trying
Don't worry
to
about it.
Required
understand
Request
what all
signature.
of this is.
Yeah.
I'll look at it later, I guess. Okay. I'm just thinking out loud.
Mm-hmm.
Okay,
So
so
this-
you said that there's two forms, and that's what the ASM is.
Yeah. So this is the signature. So to unlock this, you need two things: the signature, and then followed by the public key. So actually, if you run this, you can unlock it. Right. But here, to clarify, I'm saying this because this is the same transaction. So this one is not spending this one. I'm saying the previous UTXO, this one is spending from, has almost identical script as this one, but somehow it's not showing very well. So I'm not showing it. Does this make sense now? The signature. This is signature.
So it's the signature in ASM form.
Mm-hmm.
And what we have signed is a hash of a
Correct.
pre-image.
Mm-hmm.
Okay.
And also the Sighash type we are using now is
Yeah, I
we
think that
use
makes
all.
sense.
We use all. So basically means all of this input outputs, this output, you cannot change it. You cannot change the script. You cannot change the value. It's covered, right? Because
Yeah,
otherwise
it's been signed
people
already
can
by
change it.
Sighash all.
Yes. So if you, for example, if you change this to none, right? When you sign it, you can choose which mode you want to sign, right? If you change this to none, I can change whatever here. I can change it to whatever I want. I can deliver this to my own address instead of this address. I can change the value amount. You know, of course, I cannot be more than the inputs total, but I can change this to whatever. Basically, this is the blank check, right? So basically, the inputs, let's say, is one. How many beacons we have? Okay, it's not.
It doesn't show any input because it's part of the
11.
previous UTXO, unfortunately.
Oh, it has zero. This many. It has like I think it's this many bitcoins. So you can change. If you use none to sign it, you can change whatever you want.
The outputs,
This is the
yeah.
amount. Yes. So instead of, let's say, 547, change go into this address. You can substitute with, you can replace this with your own address, right? Basically, you are stealing money, basically, right? If you can intercept it. So that's why you have to be very careful.
No, it's not stealing if they signed it that way, but
Yeah. It's you know what I mean, right? It's not
it's
stealing.
just borrowing it permanently.
Yeah, if you are
If
like
you designed it to
giving it
be in
away,
anything.
right?
They signed it off.
Yeah, if you're giving it away. So
Right.
make sense? So basically, when you
one
sign
other
it,
thing I think is
go ahead.
I was just going to mention that ForkID is probably, I guess, something we should point out because of you know, people are going to run across it when they look at this. Unfortunately, it's a
Yes.
big mess. But if you see ForkID, just know that it needs to be set for BSV, and it differentiates between a Bitcoin BTC transaction and a Bitcoin BSV transaction. But BCH is also has ForkID, so
ForkID, yes.
there's a whole other thing there. But that's all I wanted to point out.
You are mute. You are muted, Kevin.
Thank you. Yeah, it disconnected me and reconnected me. So I'll watch it back later to see what you guys are talking about, but I didn't see the past maybe 5.
We are talking about the ForkID because you see it. We not only have all, we also have this Sighash type called the ForkID, right? And Ty, if you want to do it again, sorry.
Yeah, I just said that ForkID is a big giant mess, and it really shouldn't be there. But what we need to know is that in BSV transactions, at least at the moment, ForkID always needs to be set. It differentiates. It was designed to differentiate at the time. Well, BTC transactions versus BCH and BSV transactions. So BCH transactions and BSV transactions have to have ForkID set to 1. They have to have that ForkID in their SigHash, whereas BTC transactions do not. So if you're using a BSV transaction, you're going to see ForkID, but you should just realize that it's something that has to be there, and it doesn't even do what it's supposed to, because BCH does it the same way, and so it doesn't really matter. It can still long story short is just see that it's there and know that it has to be set for BSV, I guess is what I wanted to point out.
Yeah, it's just a remnant. It's a remnant from all the different forks that didn't have to take place but took place, and we need it to identify that we're on the BSV chain.
Yeah, even though it doesn't necessarily
right?
do that entirely, because BCH does the same identifier as so it identifies that we are either BCH, BCHA, BCHN, or BSV, but not BTC. So I think that's because it happened on August 1st of 2017, and then it never got like changed or anything else since, and I don't believe so.
So then that it says all vertical line ForkID.
Yeah.
So the vertical line means it's inclusive of both of those.
Yeah, it's a logical OR, right?
Yeah, it's a logical OR. Okay.
Yeah, if you come here, right?
Logical OR.
It's the same. It's the same here, right? When you do anyone can pay, you always edit the yes, anything else, because this means you have both options turned on. So actually, even you have
it's a
1, 2, 3, 4, 8.
It's a bit. So
yeah, it's a bit or, right? That's what I'm saying.
Okay, it's a bit or. So these bottom ones are all or anyone can pay, none or anyone can pay.
And all 6 of them would really be or ForkID as well, because that's just how we do in BSV.
Yeah, so all 6. So you just said all 6 of them. So all of these would have to always have the
ForkID
or ForkID. Interesting.
Only on BSV though. Well,
cool. Only on BSV. Okay. Yep. All right. Cool.
And, yeah, since we're talking about this, basically we have 1, 2, 3, 4 flags, right? And we're not even talking about forget about ForkID for now, because it has to come into with everyone. So this 4 actually you cannot usually when you have 4, right? You are talking about 4 factor 4 of combinations, right? But you can only have 6. You can, for example, none cannot be combined with all, right? Because it doesn't make sense. It's either none or all. You cannot be both. So only you can have 6 combinations in total. So just want to highlight this, because they're 3, right? It doesn't make sense to mix them all. Yeah. Okay. Another comments?
So
questions?
anyone can, yeah, okay. Yeah, I think I get it. Because the anyone can pay is just it's an addition to these original 3.
Yeah, these 3. Think
so we
about
have all, none, single, anyone can pay, and ForkID, and then these are just 6 of the combinations that are the most logical. It's like
the only
those are the only ones that would really work.
Only ones that are legit.
Yeah, the only ones that would work. Yeah.
Yeah. So basically, think about the way to remember
That's
this.
what I meant by the most logical. The only ones that would work.
So all this modify the outputs, right? It doesn't. If you only use these 3, the inputs are always all signed. You notice all the inputs are covered, right? And
all the inputs are covered. Yeah.
You see here?
I see that. Yep.
So you can only, this all means all outputs, none means non-output, single means only the one output.
One output.
So
I see
that help you memorize it. That's how I memorize it. So anyone can pay means, you modify the inputs. You only cover your input. That's it. Any output.
And then the
other inputs you can.
And then the all is for the outputs, and it follows the same pattern on the top.
Yeah, always output.
So then all, none.
None,
okay.
Single.
So outputs on the top. And
if you did that, if you did it on the bottom where you did anyone can pay first, straight line all, then it would make a lot more sense to people that are trying to learn it. You see what I mean?
Yes.
Is that possible with the bitwise OR? Yeah, it's possible. It's just
It's
cleaner
the same.
because anyone can pay is on the left for the inputs, all is for the one on the right for the outputs. Okay, I see that.
Yeah, for
Cool.
my defense, I take this from Mastering Bitcoin. So that's
Okay.
why you don't see the ForkID.
Antonopoulos book?
Yes, yes,
Oh,
I have to admit, giving credit to him. So where is due?
Yeah. Well, it's
We
good.
want to
I mean,
talk
these diagrams, these are very valuable. And there was actually this book, it was, or not this book, it was that, I've already sent it to you guys. I think it was the first meetup that I showed. And it's this guy called Brett Victor. And I think he, and again, you know my whole thing on climate change, but he worked with Al Gore to like build this super interactive thing for visualizing the CO2, whatever. And it was whatever, okay. But the point is that his way of doing it was really, really, really awesome. And what you can do is you could interact with all these diagrams. And so for somebody who's a tinkerer like me, like I just bought this like Arduino. You know, you guys know the Arduinos? Yes. And the instruction manual is set up so cool. It's like so brilliant, and it's like it teaches you so well. I wish I could go grab it, but I don't want to mess up all my seating arrangement and stuff. I'm in like this lounge chair that I have to, but anyways, it's just really well polished, and you just grab this book and you go through it and everything makes sense. But there was so much thought that went into that instruction guide, and it's all these little things that we're talking about, like, you know, like this diagram would preferably like show itself in a bigger way in our original thing, but right now it's just an eclectic mix of a bunch of different stuff from a bunch of different sources, and so it's difficult to follow along with what's happening from slide to slide, I think. But I'm not criticizing, it's just this is what happens. You have a rough draft, and then you have a editor that looks at it and maybe gets confused or not, and so I'm just helping you edit this so that.
And the good thing is that all this feedback has been recorded so that, you know, it can.
Yeah, for sure.
Can live on.
Yeah.
Yeah. We're
exactly.
good to have
because other people are confused too.
We can have the updated version called Mastering Real Bitcoin. So with a corrected ForkID and also swap the anyone can pay with all.
Yeah, but then you can have that on one page, and then you can like flip the page and we say, we're just going to ignore that because, you know, we're on BSV. And so then we can go to this, but on the previous page before this, you might have the ForkID option. Yeah, I mean, writing books is so much effort, making videos where they're clear and understandable. It's like a whole science, man. So there's this education, it's called NLP, and that term is used, it's an acronym that's very used, but it's this term called neurolinguistic programming. And it was these guys that John Grinder and what was his name? Richard Bandler. Have you guys ever heard of Tony Robbins?
Yeah.
Self-development guru. Yeah.
Yes.
Well, Tony Robbins basically took all this stuff from these two guys that created NLP, neurolinguistic programming, but they teach you how to talk in a way that actually makes it super easy to teach people. So anyways, I'll put a link in the thing, but it gets very deep into psychology and that kind of stuff. So I consider all of that stuff, well, not all of it, but I used to like really plan things out by understanding NLP before I made any sort of video. And now I'm kind of in the category where it's just unconscious competence. And I'm not saying I'm perfect at it, but I don't even think about doing it. But I used to plan like all my words to follow these techniques of NLP. And it's worth learning if you want to do videos and stuff, but because everybody always keeps on asking me, do my videos. I'm like, why are people asking me? I'm like the one person doesn't know anything. You know what I mean? It's like the weird, you guys know so much more than me about this stuff. And I don't get it. And it's really bothers me because I want to do other stuff, but I have to do these videos to keep people happy. But But and I'm happy to do them, but I just it really is, it interrupts my life because I get so many comments and then I don't know, and I don't get paid for doing them. And so I wanted there to be a way, if I'm going to put in all this work to do it, like I want to, maybe I should create a Udemy course or something. I don't know. But
Yeah.
You should.
But I first need to understand it. So I have to go through this process with you guys to understand it. Then I could help make a polished video. But
you should team up.
But yeah,
someone.
NLP is good for teaching techniques. All right, I'm done talking. Go ahead, Mike.
You should team up with someone who has like technical knowledge but doesn't have the teaching skills like you have, because like,
yeah, I mean, I don't even consider myself to have good teaching skills. I've never thought myself, but then people keep on saying that to me, so I guess I do, but I'm like, I don't know. But if I were to attribute it to one thing, I would say it's the NLP stuff. I mean, that's an identity that people put on me, that I have good teaching skills. I didn't know that until people started saying it. So, and I'm just giving credit to NLP. And if somebody else wants to learn how to teach, they should read that stuff, I think. But thank you guys for saying that. Like, I guess I have good, but yeah, and I guess that's kind of what I'm doing now. I've always been interested in sCrypt just to learn, and then I kept on promising Chow Wei that I would do a video to help you know, make it easier for people to understand, but I just don't understand it yet. And so until I understand it, I can't make a video explaining it because I don't have anything.
Yeah,
but
now
now
you
we're
understand
doing
it, right?
Yeah,
Sighash
and people can
types,
learn
right?
along with me if they're really.
Yeah, now you
yeah,
understand it, right? So you can.
Yes, I understand it better than I did, but I'm still gonna have to look over what's happening. I just have to have the broader context of what's happening in a message.
Quick question.
But we can go on to
on
different
these
contexts.
transactions. So who can spend these transactions? So anyone can pay, but who is spending these transactions? These, is it anyone can spend them, or is it
the ones that are defined by outputs? So the outputs lock up the coins, and then whoever can redeem that output can then. So you could have multiple outputs and have multiple people who could spend, but whoever has the ability to unlock the script associated with that output and a future transaction would be able to spend that output after it's been created, if that makes sense.
So basically what you're asking is different. It's also in the name, right? It says, for example, this flag is called anyone can pay. It doesn't say anyone can spend, right? That's a different stuff. There's no flag called anyone can spend. So basically this anyone can contribute the money, but whoever can spend it is always coming back to here, right? So you have a locking script. Actually, let me come here. So in the output, you have a locking script, right? In the input, you have unlocking script. So basically, it's a lock up your fund, and then if you have the right key, you can unlock it. Only this person.
Yeah.
It's like you have your room, your house, right? Yeah, you have your key, your lock, and only you. Hopefully, only you or your family have the key, can open. You don't want somebody else to have a random key come here, lock your funds, open your house, or spend your Bitcoins. That's not good, right? So that's like, I wouldn't call it anyone can spend. You can design the lock such that anyone can spend it. For example, right? The lock is just a mathematical function, right? You can say, oh, whoever knows 2 + 2 can spend, right? You can do it, right? You can write the contract in that way. I mean, Ty is laughing, but yes. Go ahead.
Can I ask if you could clarify? Anyone can pay for what? What can they pay for?
Can fund the transaction. I think.
Yeah,
that's kind of what I'm driving at, right? Yeah. What is what is it that they can pay for? Because that's probably what the person was asking.
Probably a better word would be anyone can fund or something like that.
Yeah,
that would be better. And we have to remember, we have to flip these. Somebody should just like do it right now, but I don't think it's text-based, it's image. But what should happen is we should have the anyone can pay on the left and the all on the right, because the anyone can pay is standing for the inputs right there. And so it's just saying that multiple people can contribute their own inputs. So anyone can fund this transaction. the inputs are open. Okay, go ahead.
So my understanding from a use case perspective is like, so for crowdfunding or something, so we want to build a road, anyone can fund it, and
Right.
then you know, the spending is going to be when the contractor is ready with his, you know, team that can start building the road, right? So if he builds, and the script will be, if you build the road, then you can spend it. And that is going to be defined by the script itself. So something like that is what I'm understanding the use case, right? So
Right.
yeah, so
Okay.
yeah,
So then
yeah, it makes sense.
good. And then the outputs are either you're going to sign all of the outputs, you're going to sign no outputs, and if you're going to sign no outputs, that's if you want to do a mathematical function like 2 + 2 equals whatever. Is that right, Chao?
That's one use case. I think you can do anything, right? You can say, oh, you need the signature.
Yeah, but I'm saying,
pending,
like, if you don't,
basically I'm
because
spending my money, and anybody can take whatever that's in the UTXO. That's fine. I'm like a crypto billionaire. Man. Throw up some coin. It's like,
let me.
So now, if I use analogy, it's like you go to the street.
True.
You just you throw all your dollar bills into the crowd. Whoever can take it can take it, right? That's none. That's none.
But that's not necessarily true, because there's going to be a locking script on it.
Yeah, but
and so the locking script is,
I already provide the signature. The signature is already in. It's signed with none, right? So imagine this. I come back here. So imagine I have this transaction. I put this none here, right? That means this output can be modified whatever way you want. So this is already signed. You see what I mean? For the previous, it's already unlocked. The coins already authorized to move. It's just where does it move to? You can change it, right?
Yeah. So you've authorized all of the outputs with your signature.
Yeah.
But
if
saying,
you change it to none, yeah.
A good way to think about it would be, like, for example, you sign a bank check, but you don't specify to who you send the funds, right?
I see. Yeah.
And then I hand you this check, and you fill it in to whomever you wanna give this money, and then you go to the bank. That will be the same as broadcasting to miners, right? Going to the bank.
But here's the thing:
check it in.
There's but here's the thing: there's some scripts, locking scripts, that actually don't need a signature. It's like 2 + 2 equals whatever.
Yeah, we should also stress the point.
And so in that case, there's no reason to sign it, because you don't need to inject your private key into the transaction. Because
if there's no check sig, you don't check sig, right? You only check
exactly. So why are you signing?
Yeah, that doesn't make sense, right?
Exactly. So in the very simple examples that you give in the demo, where it's like, you know, if the input matches, then there's no reason to do you just do none as your
no, you don't. There's no signature
even
even.
There's no signature. Wouldn't even be one.
There's no signature at all.
No signature, no Sighash.
Oh,
it just all goes away. It's completely gone at that point. I've yet to actually see many transactions that have a no check sig.
I gotta look at the demo.
I kind of try to understand what Kevin is trying to say. So basically, you unlock your input. I mean the money using your signature, but it can still be locked using a different script, which can unlock those money once those script is validated. So something like 2 + 2, which is not a signature, but it's not a private key or so forth, but it's a separate script which needs to be validated to unlock those money.
Yes.
But technically saying that it's out of my ownership. The money's out of my ownership because I've unlocked it.
Yeah, but you're the
signature.
I mean, but it's basically okay. The way that I see it is you've created a puzzle that's now out there. There's a locking script, and it doesn't involve any private key, but you have to input the right thing to unlock it.
I think that's what I see as the best use case. But and some people just like Jiawei was saying, somebody just want to throw dollars out there, and there is no script or anything as such that can be
but they're
done
not
as well.
throwing, but and this is the point. I'm not trying to be mean. I want to clarify this. You're not just throwing away dollars. You're just doing a super easy puzzle, because there's still going to be a lock-in script, right?
No,
in
that's
some scenarios, but
Yeah,
not in all.
Depends on whether you're Sighash none or whether you're signing a script that is very easy.
I think I think
there's a
there's
distinction.
two cases you guys are talking here. We have to differentiate these two. First type
Okay.
is
Yeah.
you have check sig in the locking script. When you sign the signature, you use a noun. That's what I mean. You throw dollars into the crowd on the street, right? But here another one is you have a simple locking script. So a lot of people it doesn't involve. There's no signature checking. For example, if you know
Right.
the answer to 2 + 2, right? You can take the money. That's not throwing money. It still requires you to see, oh, what is this? What's the? You need to figure out the right key, right? You still have to do the math thing.
Right.
Oh, I have to give 4. Right?
The right input.
That's not throwing money. Yeah, that's
Right.
not.
Yes.
It's two
Yes, yes, yes.
scenarios. Yes.
It's okay.
Yeah, I think that's the latter one is where I see the most use case in terms of like the real world use case where you can like let computers do some programming or whatever, let it run like smart contracts, even like Turing machines. Have a script set so that it can only be unlocked when that validation happens. Or even the real world case like crowdfunding and building roads and such, we can use this use case. So yeah, that makes so much sense now. Thanks, guys.
Yeah.
Got it.
Okay. Yeah, I'm glad
Okay,
you brought this up.
And
Yeah.
then just to summarize,
Go ahead.
yeah. And so it makes a lot more sense, but you can have this simple idea of unlocking scripts and locking scripts. And I understood that always from the very beginning, but there's these other layers of complexity that I didn't understand. And one of the reasons for the whole Sighash or message signing, whatever, is that you can't just throw your private key
a knowledge barrier
in the public. You can't throw your public key on, or sorry, I was trying to understand what Ty was saying and I lost my train of thought. Hold on. You can't just throw your private key on chain. And so you have to have this other abstraction where you could inject your private key into an unlocking script or locking script in whichever way.
You don't inject it.
This is where the whole idea.
You just sign with it, yeah.
Well, you don't inject it. You don't inject it, but you prove that you prove that you have a private key that matches through usually the whole op check sig and whatever. And so you are that makes sense. And that's why we have the whole Sighash types. And then we have to say, okay, which of these inputs and which of these outputs do we actually want to sign to allow proof that we have the private key? And there's some types of lock-in scripts that don't require any signature checking, like the
one I'm showing, right? Traveling salesman, right? If you don't put check sig there, you don't have signature, right? That's why people say, I mean, this is a little bit this is the Turing complete means, right? You can specify any arbitrary like a locking condition you want, right? You can say you need to show you have this you possess this private key, or you can say I know this result for this 2 + 2 this expression, or I can solve this equation, or in this case, right? I can even say if I can find this the shorter route. Let's say I can traverse all the US cities in, I don't know, 100,000 miles. I can find such a route. I can take the money, right? It doesn't have to be involve signature. It's just it's a popular way to specify locking. It doesn't have to be.
It's just a mathematical function.
Yeah.
Got it. Okay, that makes a lot of sense, and this was very helpful. So thank you.
Yeah, this is more
areas in which Bitcoin allows things to sort of compete, such as you can do Sighash none, or you can do a simple locking script, and we can see which one of those is the best for distributing distributing money, like throwing dollars out, so to speak, right? Or you can do check sig or not check sig for different puzzle types, and Bitcoin allows all of those things to compete with one another on an even sort of playing field. And so we'll see which ones people go with.
Great. All right. Well, there was this answers everything for me. This answers. Okay,
Can you hear me?
Samir wants to talk.
Now it's good. Yeah.
Yes.
I see you're moving your lips, but I don't hear anything. Okay.
No, I was saying like that's why Bitcoin is so beautifully created, like with using the UTXO model. It's a Turing machine. I mean, Turing complete, but people fail to understand, right? So, and it's so beautifully managed, like with less resource. So there's a UTXO that's unspent, and it can only be unlocked using certain conditions. And like unlike the account model, where you just the resources are just constantly saying, okay, it's being in use, and trying to figure out the solution. But in UTXO, it's just the script is out there, somebody finds a solution, that's when it really runs. So it's like unbounded. It seems like it's so unbounded, running forever, but it really doesn't in terms of the resource. It's such a beautifully created concept, and UTXO Turing machine complete, and thanks to Zhao Hui, with your videos with Craig, right, that helped me understand, how Bitcoin is Turing machine, Turing complete. It's just amazing.
Yeah,
it's cool.
That's all.
And so then I was gonna say, I was just gonna say that you answered my question, and thank you. And then I remember in the Slack there was a bunch of people that said they wanted to ask other stuff, and so I was just gonna say thank you, and I'm done talking.
Okay, man.
And that was all I was gonna say before you talk, Samir. Right.
Yeah, I think the beautiful thing about this model, I think a lot of I think I'm going to give out more examples, but I already have some examples. So think about, let's say this traveling salesman problem, right? Or you want to find, let's say you want to solve some Sudoku, right? If you're using Ethereum, how do you solve a Sudoku? All the miners on the network has to solve the Sudoku and the plugin, right? That's how they write. But it's general. I think all of us have been through like a math, right? In general, it's much easier to check somebody's proof than prove something yourself, right? For example, you want to check this number is you want to find a hash, right? It's the same thing, right? If you're like a minus, you want to find this nonce such that the block header hashes to 100 leading zeros, right? It's very hard to find such thing, but once you find that thing, it's very easy to check, right? This is so-called, if you're like a computer science, it's called, NP problem, right? So basically it means it's much, it may be not, it's usually hard to find a solution, but once you have the solution, it's very easy to check, right? So that's why I think this is the UTXO model, the beauty is coming. You don't have to run the complex, the computation itself. You only have to verify, right? I don't care how you, for example, I want to have this Sudoku, right? I don't care. I'm like putting a boundary there. I put this lock in the output says if you solve this specific Sudoku instance, you take my 1 Bitcoin, right? And I don't care how you find it. You either find it by manually doing it, you wrote a program doing it, or you find it from someone else's website or whatever. I don't care, because to me, I only want the solution. You plug in the input in the solution, you take my money. And this is the whole point, right? The whole point for smart contract, right? I don't have to trust you, right? Because without this, there's no any other technology, right? If you give me the solution, I may not pay you, right? If I pay you first, you may give me the solution. But this is beautiful, right? This is atomic. Either you give me the solution, you take my money, or neither happens, right? So I think that's why I think it will be beautiful. I think I'm in the blog. That's why I try to explore all the simple use cases. But this is like a super simple example. You can expand to any kind of computation you want, right? I just talked about Sudoku, a traveling salesman, or you want to go ahead.
I just had a really important idea I wanted to express, and that's why I kept on trying to interrupt, but I'm sorry for doing that, is that what we keep on doing constantly for the past 2 years is going from the Ethereum paradigm, and we're trying to translate it into the BSV paradigm. And that's a very difficult thing to do because I don't, it's like just, and so what I had the realization of is, how about we just never talk about Ethereum again, never talk about the account-based model again, just completely erase that from your mind and say, look, this is the UTXO model, and just start fresh and explain how the UTXO model works and the benefits of it. And then I won't have to carry all this old baggage.
Yeah.
It's like, there's a term in spirituality, it's called Zen mind, beginner's mind. You can look it up if you want, but you just look at it with fresh eyes. And so instead of trying to compare it to something old that makes everybody confused and there's these bulky metaphors, just this is what we do with the UTXO model. We have a time chain. And, so
Ethereum is superior when P equals NP. But unfortunately, P does not equal NP. At least until that, you know.
Not so soon.
Make some
well,
people
if you
mad
break,
by saying that.
if you break that, then you. This is what Craig was talking about in that thing. Is if you make it like what you just said, then you break public-private key pairs.
You break
right?
everything.
Yeah, and so then you don't have anything, and so then we'd have to reinvent an entire new type of time chain.
You'd have to build an entire human belief system up, starting with nihilism as a base. If you don't have anything, because everything is exactly, you know.
That's singularity.
So that's what I'm saying.
We
let's
should
just forget about Ethereum. It's flawed logic. Just forget about it. They're not successful.
Right. You said it's very difficult.
Yeah.
You said it's very difficult, and I was refraining from interrupting you, and you said it was very difficult, and I said, well, yes, it is very difficult because of the fact. So yes, it would be difficult, wouldn't it?
That's only possible if n is 1, and that means singularity. That means like all of us are like,
but
that's a whole whole new discussion.
That's a whole other rabbit hole.
Okay, wait, that's actually a very interesting concept, because you guys were talking about this, and Craig actually posted something that I was really trying to figure out and I couldn't, but he was talking about where if P equaled NP, if P was 1, whatever,
N was 1.
Samir, I gotta pull this up if I really want to quote him specifically, but then everything would be solved instantly or something. And I wanted to understand better, what is N and what is P? What are you guys talking about when you say that? Because I've heard that term, but I don't understand it.
There's the ECDSA thing, but the way I'm looking at it is N is the number of entities. So when I say P, when P equals NP and N is 1, that means like, because it's only possible when N is 1. That means like we are. When I say singularity, it means like all of us are doing exact same thing. Like, and this is from a philosophical human perspective, right? This is not a Bitcoin mathematical thing. I'm talking about from a philosophical perspective. Like everybody is doing the exact same thing. That's pure communism, where everybody's following the same rules. Right. Everybody's basically there is no diversity. And Ty, that's only possible. Yeah.
And that was your response.
That's what I meant.
Okay, and I'll let you, but Ty, that was your response to Craig's post when Craig posted that. You said that sounds like communism to me, and then that just matches with what Samir just said. Are you Samir? Are you in the MetaNet ICU?
I'm not, but I
no.
Yeah,
okay, you're not. Okay, so I'll send. I'm pretty sure it was in the public channel, and we're allowed to share from Bitcoin General. So if Craig posted that in the Bitcoin General, then I'll take a screenshot of it.
I said in that thread, you can share
it
as well. Yeah,
okay, thank you. And I'm allowed to do that, I think, as long as I have permission. And I just got permission from you, and I have permission. I'm pretty sure Bitcoin General, I can share screenshots. All right. So I'm going to try and find it now.
While you're doing that, I wanted to.
You're muted again, Samir. You're muted again.
I want to add. Okay. Yeah. I wanted to add, can you hear me now? Yeah. I wanted to add to the point that you were mentioning about, finding a solution and verifying it. So that's in addition to what you mentioned, right? So in terms of the mining community, what they do is everybody's trying to find that one solution. And once that solution is found, the incentive is to distribute that solution to everyone. And that's the most beautiful part. And I have an analogy to that, to the real world, right? So so for example, if I have some beautiful idea in a traditional model of doing business or doing things, I'm incentivized to hide that idea, to make it secret, so that I can build on top of it, and that requires a lot of overhead. And I want to relate to what Kevin was mentioning earlier about creating videos and so forth. The beautiful thing, that the thing that you really love to do is something else, but you want to build videos and because it's a need or so forth. But what you really want to spend your time is what you really love to do all the time, right? So and for the traditional model, when I have an idea, because the 21 million supply and the limited supply versus the unlimited supply of the US dollars, in the traditional model, it is incentivized for me to hold on to my idea and keep it secret so that I can build things around it, so that I have the control. And once it grows, that's when I can get more benefit out of it, right? And that was necessary in a traditional model, where the monetary policy that say a dollar that I have today has more less value tomorrow. But in a Bitcoin model, because of the limited supply, I'm incentivized to share this idea out, so that I can continue doing what I really love to do. That is, like, say for you, for Kevin, for you,
well, yeah,
not doing videos but something else, and for me, like, just coming up with ideas, finding solutions, and so forth. So I just continue doing what I love to do, but then this idea can be shared out to the public, so people can just find, if they think it's a good idea.
Okay.
People can just find it and build on top of it. So as a whole, like I know Craig talks about the society is moving at a highest common denominator, right? So from a mathematical term, so if I'm at a pace of 10 and you're at a pace of 8, the traditional model is we are together. When we come together, we work at a pace of 10. But in a Bitcoin model, we work at a pace of 40. So the society is going at a very fast, rapid rate, and that we can see even in BSV community as well. So yeah, this is such a beautiful thing with the proof of work. Like, in addition to what Xiaowei was mentioning, just because you can find a proof, you can find a solution, you share it out to the rest of the miners can quickly validate, and we move on to the next problem. So the only race is time. So it's just a beautifully organized concept of yeah. Go ahead.
Everything that you just said there is the benefit of creating patents. Okay, and people don't understand this at all, of why do we create patents in the first place. And we had a really good discussion about this a while back in the MetaNet, where I just realized, oh my God, that's why we create patents. And so if you don't have patents, okay, and because everybody gets mad at Craig for doing patents, but if you don't have patents, you have no incentive to share your idea. And so you just said in the Bitcoin world, you have an incentive to share your idea and then move on to the next thing instead of keeping it guarded. Well, that's why patents were invented in the first place, is that people would be dying with their ideas all in their head and nobody could recreate, for example, this certain type of dome back in Europe. There was only one person that could do that, and he would never share how to create that architecture. And finally, they said, look, okay, you know how to create the dome, but when you die, we want to be able to recreate it. So write it out, and we'll give you a monopoly on the dome thing for the next 20 years. And then when you die, we have the trade secrets, basically, or we have the ability to build the dome, okay? That's why we've created patents. And when you understand that, you understand that patents are not selfish. It's the opposite of selfish, because you're sharing all your ideas and they'll be accessible long after you die to everybody. Whereas before, you just keep it to yourself.
Definitely. I fully agree with
and
you.
So
and I think it's
and the reason I'm always sharing, go ahead.
Yeah, and I think now we have finally a system that it's native to this Bitcoin ledger. Now we can just publish a hash to the ledger, and it's so efficient. We don't have to go through the whole patent process. It's just the same concept, but it's just a timestamp. It's much easier, digitally doing that exact same concept of patenting. So yeah.
I mean, you're still going to have a formal way of doing patents, I bet. But yeah, and this is why I kept on saying micro patents. Like, this term keeps on coming up. And when I was doing my previous video to the one before Craig, I was talking about examples of how we could use blockchain to do a poor man's patent. And a poor man's patent is where like you put something in an envelope and you mail it to yourself just to get a timestamp to prove that you had that idea. And the reason it's called a poor man's patent is because you don't have to register it with the post office where you have to pay the $5,000 fee or whatever. And not the post office, with the patent office. Right. But if you go to the patent office and they say poor man's patent doesn't count. and so what I'm saying is that a poor man's patent, even though you can prove that you had the idea at that time, it isn't enforceable by courts.
Yeah.
Because you didn't pay the fee to pay for all the
but
cost
even
of the courts and stuff.
If it would be enforceable, you would still have the legal fees to actually enforce it. So that's
it's no longer a poor man's patent at that point.
Yeah,
because
and look, I am a poor man compared to somebody like Craig. I would never have the resources to go and create a patent, like a good one that was enforceable. And so as that person, I just share all my ideas. And I trust that I'm going to have more ideas, and I just want a foundation. And in the future, I'll think of the next thing to invent.
Yeah.
But we're so early in the Bitcoin thing that I'm a higher level developer, and so I just share. I mean, there's some stuff I have ideas about, but that I don't share. But if I have an idea, I almost always just share it,
but especially with the native token, right? So the Bitcoin token itself, the limited supply that I was mentioning earlier, because at the end of the day, patents or whatever, of course, patents. There's the people want appreciated for their originality and for their ideas, but also in monetary terms, we want to have value of something that you possess. So if you have some idea so for example, in my head, I'm an idea guy as well. So I'm incentivized to share this idea out to the BSV community is because I think BSV is going to be the longest chain. And as long as I hold some sort of the native token, some native token that is on BSV, anything that's built on top of BSV, that means the idea that I have built into application, then the value obviously I'm gonna have more value tomorrow for that same token that I have today, right? So now I feel like I'm incentivized to share this idea, because as more things are built, as better things are built, I have the value with me that I can use in this, in that application more. So for example, say farming. So if we build applications for a supply chain for farming, like for transportation, for Uber, homes, yeah. Airbnb, anything on BSV, the token that I have is going to be valuable, and I can use this token tomorrow. So it's naturally incentivized for me to do that, and I think that's what gold standard was better, and it was the fastest growing, and we had all these idea people then with creative new ideas back then in the gold standard, is because of that security that you get with the tokens that you hold, the whole gold that you hold, right? So it's not technically like it has its own flaws and everything, but it's a security that you get, that tomorrow, and that the thing that you mentioned, the trust, right? So you can now finally trust, even though somebody says, oh, idea, but who cares? The tokens that you have today proves that you came up with the idea because you believed in the token. You bought that token before, as soon as you came up with a new idea and you published it out. So I think naturally it's this protocol, this philosophy in Bitcoin allows people to be more open and transparent, and because it's not like people are saying just be open. It's economically incentivizing people to do that. There's value in doing that. So yeah.
And that's one of the things Craig said in that interview, which is Bitcoin is not a cryptocurrency. He said, if we want to have great works of literature, if we want to have great art, we actually have to incentivize these people to share their work of art and to create their videos or whatever. And that is what patents allow, but also what you're saying, and you never use the word patent. I was just trying to link that to you. But what you're saying is actually true, is that Bitcoin is kind of allowing this same situation to occur. Even something in just like a YouTube video, like I'm happy. I remember there was this one time I wrote this long post on a YouTube video in response to somebody's comment, and then he deleted it. And I'm like, oh, like, and for whatever reason, it pissed me off. And then I traced back, why is that? And it's because he just stole all of my work. Whereas if it was still there,
Right.
if it was still there, then I can prove that, look, I told it to this person at this time, and it's all public.
Yep.
Right. And so there actually is some incentive for me to be sharing on YouTube publicly when the cameras are rolling, because I'm documenting stuff.
Mhm.
See what I mean?
Yeah.
And so what you're saying, I think that's what you're saying, is that somehow Bitcoin allows people to share more openly.
Yep.
And that'll allow us to have like a golden age, essentially, of better architecture and stuff, because people are sharing their ideas.
Well, it allows it, but it also gives people the freedom to not, which is also very, very important, because picture the alternative. If everybody had to, then you have this thing where, you don't actually derive value. So that's the other dimension of this, is that yes, you are encouraged to by the world, but you are also given the freedom to not, because then you have something that you can build up. You can keep certain parts secret as you're building up a longer term thing over time, and then eventually, when you're ready, or set up certain conditions so that if you die or something, then things get released. But then you can share things later. But in the meantime, you can have hashes of things that aren't public yet, and have the freedom to not, while still making record. And that's a really important thing too.
Exactly. Yeah. Right when you started that, I was trying to fill in by taking a hash and publishing it for you.
Yeah.
But you just said it at the very end, but I just want to put it there so people knew what you're talking about. But yeah, I totally agree. And that's super valuable, because if you're saying things publicly, then it's like live, like I could live stream my whole life, but that would be very disruptive to my life, because people would be like trying to intervene, and that would be awful. But by like keeping a private record of everything that I'm doing, then I can attest that I was doing this, or I can prove that I was doing this later without being a live stream of my whole life. So yes, I agree with what you're saying. It's very, very, very valuable. So
I maybe want to.
I just wanted to go ahead. Go ahead,
Sorry,
Steph.
no, I maybe wanted to mention something related to what we were talking about earlier, which is Sighash, right? So one of the things which I guess we were talking about was the fact that in order for what we were talking about with different Sighash flags in certain circumstances to make sense, we have to consider that the transaction on the right-hand side of Xiaohui's diagram, TX1, that transaction is offline. The thing that we didn't mention is, of course, that this offline movement of the transaction and passing back and forth is actually where we start talking about payment channels. So I think it might be worthwhile to, at some point in the future, to do a follow-up chat where we start talking about the different types of payment channels, because there are actually different types of payment channels that fit different types of use cases that are very interesting to look at.
And you just connected the dots for me of how that fits in, because I had heard the term payment channel, but now I get it. It's like you're trying to construct this form of payment, like you have the check, but then there's a process. Somebody has to sign it, somebody has to endorse it, and then you put it. And
Right.
there's that offline payment channel, or that offline, but you're still connected to the internet, because I have to send it to your computer, et cetera, et cetera. But
somehow,
but this is all a payment channel.
Somehow it gets
and
exchanged.
then
you could essentially
it could be on paper.
Exactly. Yeah.
I can literally
But
email
then
you
once
the
that's
transaction.
finished, then we put it on the blockchain.
I can literally email you the transaction as an attachment if you have the right software.
Yeah, wow.
If I had
To
the
decompose that.
right software, I could use this here UHF radio. And
You can actually print it out
but
and
yeah.
mail it to you, right? I can literally print out the transaction,
Right.
text, mail it to you. That's why it's a peer-to-peer, right? You don't have to go to the bank. I think that's a beautiful.
RFC 1194.
Hang on, that's avian. That's avian.
Yes,
And technology.
that's what I was referring to. RFC
Avian carriers.
1194. I wrote a Bitcoin adaptation of RFC 1194, and I posted it on the MetaNet Slack on April Fool's Day of 2021. So if anyone wants to go check that out, that's another way that we can exchange partially signed transactions. And I don't know, what do you guys think next week? We could talk about payment channels.
Yeah, that'd be great.
Yeah, that sounds good. Even I have
That was
to,
Stefan's idea.
we have to do some reading on it because I don't think there are many people who's familiar with other than Craig. Yeah.
And go read RFC 1194 as well, because
Can
it's
you
relevant
share
to
it?
this. I'm telling you.
Yes. Can you share
I'll
it?
put a link to it in the Slack.
Yes.
I'll
Sounds like
find
some
it.
kind of like alien technology. Is it Morse code or no?
No, you print out a little piece of paper with a hex string on it of your Bitcoin or of your IP packet in this case, and you tape it to the leg of a pigeon, and then you send the pigeon to the destination. So it's a it's a metropolitan area network wide
pigeon to pigeon network, right? Peer to peer.
Yes. So just an interesting thing there, and I'll post the link to RFC 1194, and I'll also post if I can find it, the document that I wrote up a little while ago in the thread.
All right, sounds good. I think it's all right. That goes a little bit further than the Sighash tabs I imagine, but that's what we are here for, right? Push the boundaries. Okay, any other comments, gentlemen, before we wrap it up?
Nope, that's it. I think that's great.
Xiaohui, you're gonna take the
awesome,
Zoom. You're gonna take the messages that were put in the Zoom chat before they disappear forever and put them in the Slack. Okay.
Yeah, it's already
sure
it's already there. I think it's already moved.
Okay.
Yeah, it's already moved. Phil already helped and moved. Sounds good. Okay, gentlemen, and great talking. And
I just wanted to add one before we leave. So I have some ideas on stablecoin that I wanted to run by, I don't know, Ty, if you remember from our
I remember discussing it
from the
a little bit.
CoinGeek, but just wanted to run by rest of you guys and see what do you guys have to think, because I think it's time we kind of like discuss. I know Kensei and N-Chain, they're discussing about the stable coin, like fiat based, and I've thought of some Bitcoin native stable coin. So maybe next time when we have a call, I want to discuss with you guys as well, just see what you guys think.
I mean, is
are you InfoBitizen?
Yeah. What was that?
You're InfoBitizen. Okay.
Yes.
And so you requested this earlier on the record, by the way.
Oh yeah.
I mean,
and this is what I was saying. I always said I was finished, and then if we wanted to answer these other questions that people had, so you requested this before the meeting, and that's good that you're bringing it up at the end.
Yeah. So
that's. I don't know how long that takes, but if you like 10 minutes or so, we can briefly run over, because we usually go to a 2 hours mark. So.
Okay. I can wrap it up in like 2 hours, but maybe and it all relates back to what we were discussing. The HODL culture, right? So the HODL culture is native to not only BTC but also like BSV, because regardless of how many apps we build, it does allow us to scale to like more people, and because that we have the infrastructure in BSV, we have the infrastructure to get like 50,000 transactions, 100,000 transactions to millions and billions. We can just increase the block size and so forth. But the mentality for people with the HODL culture, right? There's a 21 million supply. If I have one BSV today, as more things are going to be built tomorrow, I can get more value. So that's more of a psychological evolution that needs to happen, right? So we are really early right now, and we are building things because we are excited. We are building applications on BSV because it's out of excitement too. So we are okay to spend this money. But over time, when things get really serious, I think the whole culture is going to be prevalent, and that's my prediction, right? So we need some kind. I don't know if you guys saw about, and I think that's why stablecoin is out there in the public. Like CBDCs, like Tether, USDT, because there is no upper limit, there is no supply. And I've talked about this with George Gilder as well. The limited supply of 21 million still, from psychological standpoint, it's still a HODL culture. So I was thinking about this stable coin that just like fiat and like Tether, where you have some pegging based on the US dollars or any other currency, and you bring that into the network for one-to-one, and it requires a separate audit and all that stuff. But why not use the Bitcoin ledger itself to audit the stablecoin and mint the stablecoin as and when? And the idea is, what does stablecoin really means? And I was talking to this guy who was in the conference last couple of weeks ago. The guy from he wrote a book about stablecoin from the university. So I don't remember his name, but I really asked him, like, what does really stability really mean of a stablecoin? And he talks about utility, and ultimately we might get there when Satoshi, like BSV Satoshis, becomes that stable coin. It becomes the unit of account, unit of
medium of exchange.
Medium of exchange. But that is a long way to go, because until that point we need to rapidly either build applications, or we need a separate like other tokens and so forth. And I think stablecoin for me might work. And the idea that I have is, why not utilize the usability? The stability is on the utility, the usability. So the stablecoin is basically the idea that I have is, it'll be minted by the miners as and when transaction happens on Bitcoin. So any transaction happens regardless of the size. If it's a 10 BSV transaction, or it's a 1 BSV or 0.1 BSV, it'll mint one token, and that will be done either by the miners or the wallet itself, right? So and that basically it's like a counter of the transactions that's happened on Bitcoin. So if there's more transactions that's happened, then more tokens will be mint, but it'll be one-to-one. And the auditing is going to be using the Bitcoin ledger itself. And with SPV, you can create a Merkle proof and so forth. At the end of the day, what we're really proving is how much energy we're spending, because this is going to be a protocol created by the miners, and miners will be minting the transactions, minting the tokens as and when they mine up a transaction into a block. So as soon as they say 100 transactions mining a block, they will mint 100 tokens, and these tokens will be sent to the owners who initiated the transaction. So the P2 public P2K SH hash, right? So whoever initiated the transaction, that's where they will receive it, and the auditing automatically happens based on the Merkle proof. So Bitcoin ledger itself audits the validity of the tokens. So this, and there is no upper limit. So if you have millions of transactions on a block, there will be million tokens that will be created, and we can have a separate trading economy of its own. And that will be based on the SPV model. So it's a peer-to-peer trading can be done. So that's what I'm thinking, like stablecoin, which is still backed by the Bitcoin ledger itself, and it's basically a counter of the amount of transactions, and it'll also be a proof that we are spending 6 terahash of hash power to mine this block, but then we created these many tokens. So it'll be a connection between that as well. And over time, the ultimate goal is Satoshi's to be the unit of account, like the unit of account for everything. But until that point in time, as we mint, because there's no upper limit, so there's no 21 million on this one. There's as much as you can mint as much as you want. So it'll create a stability. It'll also incentivize people to use the transactions. I mean, use the Bitcoins, the BSVs, because
just to use the Bitcoin network in general, right?
Yeah,
and then that's what and because you have a stable coin, because you're trying. I think what you're saying, and is that if right now everybody just wants to hold BSV, they don't want to spend it. But if we had a different token that was less valuable, then people would be willing to spend it. Like I'd spend my dollars. We just want to have the spending of that take place on the BSV network. And there's a lot to talk about here. And so maybe we could have another video where we talk about stable coins, because there's this whole video that Craig recommended that's brilliant. I watched it, never had a chance to talk about it, but it talks about this exact same psychology of why some currencies are more spendable than others. It's kind of like on the black market, everybody uses toothpaste, or everybody uses this thing or that thing. And I think that would really contribute to your conversation because that's ultimately what you want to do. And it's not really nothing is stable. Everything in nature is always in flux. And so it's actually not a stable coin, but it's a coin that people are willing to spend instead of BSV.
Right.
And that's useful. Yeah.
So, I mean, at the end of the day, even when you're sending these tokens, you're still the plumbing is still BSV. You have to use the BSV. So that will incentivize people to still use it. But at the end of the day, you are getting something else for it. So you know, and you can also create an economy for that. So you know,
Right.
like you mentioned, you know, there is definitely a lot to talk about. But I just wanted to run this by you guys and see what you guys have to think, because we really need
Yeah,
a
I think
stable coin.
I have a lot of thoughts about this, but the problem is that we're coming up on 2 hours.
Yeah.
And so we're gonna do but let's make a plan to do that. So Ty said that we're gonna do in the next class, we're gonna do what were we gonna talk about next?
Payment channels?
Payment channels.
Payment channels.
Payment channels. Oh yeah, and that was from Stefan actually. So we're gonna do payment channels. Because it follows naturally from the whole understanding of the SIG hash that we started with. And then after that, we're going to talk about having, I don't want to use the word stablecoin because it has all sorts of connotations, but we're going to talk about creating some sort of token that people are more willing to spend than BSV. So stablecoins. All right.
Yeah.
Deal?
Yeah. Stablecoin in a sense that it's 1 unit all the time. So there's no price to it. So, you know, so it won't be to anything. So it's always stable. The volatility is going to be more on the BSV side, but so ultimately it's going to be a one-to-one kind of thing. So yeah, we can talk about it later, but just wanted to throw this out there.
We'll talk about it in
what do you guys
the
have to say?
next meeting, just so we can close this in 2 hours. Will be that. So I think that sounds pretty good, right?
Sounds good.
Okay, man.
Thanks, guys.
Let's keep it rolling. Seems like now
All right.
one more future topics we can discuss. Okay, right, guys. Thanks for coming, and hope to see you all and some more people next week, next Friday. Take care. Enjoy the rest of the day where you are. Okay, Stefan, Michael, Ty, Samir, Phil, Bao,
Bye.
Kevin. Okay, see you next time.
Bye-bye.
Bye-bye.
Talk to you guys
Thank you.
soon.
Bye.